How deep and scary really is ocean, and why it is unexplored? Here's something that sounds impossible, but is completely true. We know more about the surface of Mars than we do about what's lurking at the bottom of our own oceans. Think about that. We've mapped the Moon, we've sent probes to Jupiter, but over 80% of our oceans remain unexplored, completely uncharted, the deepest parts of the sea. Still mostly a mystery, and the few things we have found down there, let's just say they're the stuff of nightmares. The ocean isn't just deep, it's layered like a descent into another world. At the top is the epipelagic zone, the sunlit surface where life thrives, coral reefs, fish, plankton. It only goes down about 200 meters. Below that is the mesopelagic or twilight zone. Light fades, temperatures drop, strange bioluminescent creatures drift in near darkness. This zone stretches to about 1,000 meters. Then comes the bathypelagic zone, the midnight layer. No sunlight, the water's just above freezing. Pressure is bone-crushing. Few creatures survive here, and those that do look like something out of science fiction. Finally, at around 3,800 meters, over 12,500 feet, you enter the abyssopelagic zone, or simply the abyss. This is where the Titanic lies. It's not just deep, it's utterly alien. The pressure is over 6,000 pounds per square inch, enough to crush a human body instantly. Temperatures hover near freezing. It's pitch black, silent, and motionless except for slow ghost-like currents. The Titanic is disintegrating here, consumed by iron-eating microbes. Not much reaches this far, not rescue, not sunlight, not time. Just the slow erosion of steel and memory. Here's the thing, we've only mapped about 20% of the seafloor in detail, not because we don't care, but because it's brutally hard. GPS doesn't work underwater. Sonar mapping takes forever. Sunlight disappears at just 200 meters. After that, total darkness. The ocean isn't like land. It shifts. It's cold, vast, relentlessly hostile to human tech. Imagine exploring a mountain range, blindfolded at the bottom of a crushing, freezing pit. And the deeper you go, the stranger it gets. The environment becomes more alien, the data harder to collect, the risks even greater than space. Down in the abyss, light is useless, so life adapts by glowing, stretching, stalking, like the anglerfish with its bioluminescent lure dangling like a headlamp. It floats in the black, waiting to strike, or the giant squid, once a myth, now confirmed, up to 40 feet long, with steel shredding beaks and limbs. Then there are transparent creatures, jellyfish that flash like alien light shows, and fish that shrug off pressures that would crush a submarine. Some scientists think we've only discovered 10% of ocean species. That means there are millions of life forms we haven't seen, haven't named, can't even imagine. And if you think deep-sea exploration is just about dropping a camera, forget it. The biggest barrier isn't distance, it's pressure. Go just 1,000 meters down and the water pressure is 100 times what we feel on land, like having 50 jumbo jets stacked on your body. At the bottom of the Mariana Trench, over 1,000 times, metal warps, glass shatters, electronics die. Humans, no chance. That's why we send remote-operated vehicles, ROVs, built like tanks. But they're expensive, fragile, and limited. Every mission takes years to plan, costs millions, and if something fails, you lose everything. Exploring the deep ocean isn't just science, it's survival. The truth is, we're still in the infancy of deep ocean tech. We've sent people to the moon, but we've barely scratched the bottom of our own oceans, because physics down there is brutal. So why haven't we explored the ocean the way we've explored space? It comes down to three things: cost, danger, and payoff. Deep-sea expeditions are among the most expensive missions on Earth. A single dive to the abyss can cost millions of dollars, and that's with no guarantee of finding anything groundbreaking. Then there's the risk. Submersibles can malfunction. ROVs can get tangled, lost, or crushed. Human divers can't go anywhere near the depths we need to explore. Every mission is a gamble with high stakes and low visibility. And finally, there's the mystery. We don't even know what we're looking for. There's no roadmap, no X marks the spot. That makes it hard to justify funding, especially when governments and private investors are chasing faster returns from satellites or Mars rovers. But here's the twist. The ocean might hold some of the most important discoveries left on Earth. New life forms, undiscovered ecosystems, even medical breakthroughs hidden in deep-sea biology. It's not that we're ignoring it. We just haven't cracked the code yet. We pour billions into space exploration, chasing distant planets and distant futures. But maybe the real final frontier isn't up there. It's down here. The ocean is Earth's shadow realm. Ancient, unforgiving, vast, still mostly untouched. And despite all our advances, satellites, AI, robotics, it keeps secrets we can't even begin to explain. What's hiding down there? New species, pieces of lost civilizations, clues to how life began or how it might end. We don't know. And that mystery is exactly why it matters. Exploring the deep isn't just about curiosity. It's about understanding our planet before we go looking for others. It's about facing fear and pushing boundaries, not just because we can, but because we should. If this made you rethink what lies beneath the surface, hit that like button. Subscribe for more stories about the world most people never see. And tell us in the comments, what do you think is hiding at the bottom of the ocean? Because maybe the scariest thing about the deep sea is how much of it we still haven't dared to touch.